Good afternoon, good evening, good morning, wherever you're watching from. And today I'm going to talk about what I've found to be the new stress, and that's oxidative stress. And so there's many ways that we can understand stress. I believe there's very particular ways that we can understand oxidative stress. I believe it's the new stress. And so let me teach you a little bit about oxidative stress. And oxidative stress, it's a term used to describe an imbalance between the production of reactant oxygen species, or ROS, and the body's ability to detoxify or repair the resulting damage. So ROS are highly reactive molecules that contain oxygen, such as free radicals, okay? Free radicals lead to oxidative stress. While ROS can play an important role in the normal cellular processes, an excess of ROS can cause damage to the cells, to your proteins, and to your DNA. And the body has a natural mechanism against oxidative stress, including antioxidants or the antioxidant response system. However, if there's an increasing amount of oxidative stress, which the average person has about 300 septillion free radicals a day ravaging their body, it's hard to lower oxidative stress. And if you go to pubmed.gov and you type in oxidative stress, you'll see that it's related to over 200 diseases. It's actually at the very center of over 200 diseases. And so, to be honest with you, oxidative stress has been implicated in a various amount of studies now, as I just mentioned, and it can contribute to chronic illness, as I mentioned, Parkinson's disease, Alzheimer's, neurodegenerative diseases, cardiovascular diseases, diabetes, and even cancer. And to be honest with you, it's involved in the aging process. National Institute of Aging did a study on oxidative stress and its effects on the aging process. So when oxidative stress overwhelms the body, antioxidant response system, as I mentioned before, it can lead to damage at the cellular level. This damage can affect how your cells function and how your tissues function, leading to inflammation, leading to impaired cellular response and how the body reacts to this stress. So over time, this contributes to the development and progression of disease. And so, for example, cardiovascular disease, oxidative stress can damage blood vessels, promote inflammation, contribute to the formation of plaque in your arteries. In neurodegenerative diseases, oxidative stress can lead to the accumulation of abnormal proteins, which leads to neurological damage. Let's take cancer, for instance. Oxidative stress can promote DNA damage and mutations, contributing to develop the spread of cancer cells, okay? It's important to note that oxidative stress is not the sole cause of these diseases, but it's at the very center of it, okay? So I want to talk a little bit about the importance of what oxidative stress does. So one of the pathways in our body is called nuclear respiratory factor 2. Okay, it is a cellular signaling pathway that is involved in the upregulation of antioxidants and detoxification processes. Plays a crucial, if not the most important role in protecting cells against oxidative stress and maintaining the body's cellular homeostasis. When these cells are exposed to oxidative stress, they bring toxins to the body. The NRF2 pathway is activated to trigger a protective response. These are called survival genes. They turn on these survival genes and they compress the anti-inflammatory genes, the anti-fibrosis genes, okay? And The key player in this pathway of the NRF2 protein is bound to a protein called a KEAP1 protein. It acts as a sensor for oxidative stress. Okay. KEAP1 promotes the degradation of the NRF2, kind of like a thermostat in your health. Okay. Keeps it up regulating and down regulating. And this allows the NRF2 to accumulate in the cell and translate and go inside the nucleus. Okay. And let me just say this. Once in the nucleus, this NRF2 binds to your DNA sequences called the antioxidant response element, or ARE. Okay. And these are present in the promoting regions of various types of genes. 20-some thousand genes in our body. This binding that happens leads to the activation of these genes. It's why people say now we're no longer bound to our genes. It can be part of the detoxification process. Okay. The genes activated by the NRF2 pathway include those encoding superoxide dismutase, catalase, glutathione peroxidase, detoxification enzymes, glutathione, NAD, and other proteins that promote and repair cellular damage. So by activating these pathways of the NRF2, by activating these genes in NRF2, it helps increase the production of the antioxidant molecules. So instead of taking a whole bunch of antioxidants, you can actually turn back on the body's own antioxidant response system. So you've got an exogenous form of taking a bunch of antioxidants, and then an endogenous form where you're actually turning back on your body's own antioxidant response system to work the way God intended it. You know, there's been numerous research articles on its effect on aging. The National Institute of Aging did a study, proved that a product that I use, Protandim NRF2, was the only clinically proven product in history. It had 9 patents that actually reduced oxidative stress by 40% in 30 days. And so you're like, well, Michael, how do they know that it does that? Okay, well, there's pharmaceutical and nutraceutical research that's been being done. Inside that study, they use drugs and they use pharmaceuticals and nutraceuticals. They found out that 2 pharmaceuticals and 1 nutraceutical actually activated this pathway properly to get the benefits. Okay, so there's a lot of different benefits, but the NRF2 pathway is important cellular defense mechanism against oxidative stress that there is. Okay. And so the research is here, 30 plus different research articles on the one NRF2 activator that I take. And so let me fill you in, and we'll have some links at the bottom of this so that you guys can get some more research and even get on NRF2 if you want. I would tell you it's the only nutraceutical in history with patents and published research that I will take the rest of my life. So will my family, and so will the majority of our family and clients. We have over about 2,000 people worldwide on NRF2, and they all feel the same. And you can do your research. We will put some research links and articles down here. Linus Pauling Institute, the largest research nutraceutical university in the world, is doing extensive research on it. And the science is there, the human application is there. And so let me finish with this study. I think that's most important is that they used the product that I take, and they took people from the ages of 16 all the way up to age 80. And they tested their blood and tested their oxidative stress levels. Okay. And at the end of 30 days, they could not tell the difference in the 80-year-old or the 16-year-old. The 80-year-old was extrapolated back to that of the 16-year-old. Some of the people were actually extrapolated back to that of a 5-year-old. Okay. Which I've had mine tested numerous times, and I have the oxidative stress levels of a 7-year-old. So let's just be realistic that the longer you activate the NRF2 pathway, the better your body will respond. Okay. And so I hope that you'll do your research and understand that oxidative stress is at the very center of every disease. And there's a way that you can reduce it by 40 to 70% in 30 to 120 days. You can also increase your body's natural production of glutathione, which I will be talking about in coming videos. So thank you guys so much for listening. I hope you understand a little bit more about oxidative stress, and I hope you understand a little bit about nuclear respiratory factor 2 and its effect on sickness and disease and reducing oxidative stress. So thanks for listening. I hope you guys will subscribe and share this video. Invite your friends to share and subscribe too. So God bless you. Thank you.